Hi students, welcome back to our online classes. On the last class we discussed about long division, a little bit difficult one, division of polynomials. Did you get the concept? Did you understand it? Are you practice it? Do many problems about long division, we can easily understand that. Today we also discuss about long division. One more type of long division. The same type, a little bit different. The actual application of this method will be on our next sections. Next, remainder theorem and factorization of polynomial. The actual application will be in factorization of polynomials. This is simple one, but you can easily understand by doing more problems. This is the first time you facing polynomial division. Okay, that's a little bit tough. I know, a little bit tough for you, but do many more problems. You can easily understand this one. So here, another question. Divide 3x raised to 4 minus 4x cube minus 3x minus 1 by x minus 1. It's a polynomial division. Divide this polynomial by that polynomial. Our only one method is long division. We can divide that. But this type of questions, you must be careful about that. Here, 4th degree term is here. 3rd degree is here. But 2nd degree term is not there. Okay. At first, on long division, you carefully read the question first. First, you check all the terms are there. Constant term, 1st degree term, 2nd degree, 3rd degree, 4th degree. Then you write it in standard form. The standard form of this one is, I will do it 3x raised to 4 minus 4x cube, and the 2nd degree is not there. Don't exclude the 2nd degree. You just put, if one place is vacant, one place values, on any other things, you just put dash there. What? 0 there. So you just put 0x square. 0x square means 0 minus 3x minus 1 and x minus 1. The same thing for this also, the divisor. If the divisor is x square minus 1, who writes this x square plus 0x minus 1. This is the standard form. Square term is here and degree 1 term is not there. So you just write x square plus 0x minus 1. All are positive. Plus and plus here. Not negative, plus. More careful about the dividend part. Dividend part is small. If we ignore on the divisor part, dividend part is important. Divisor part ignore cheyidalum kuഴപ്പമില്ല. But you ignore in the dividend part, the problem will be wrong. You can see. Okay, our first step is divide this first term by this first term. 3x raised to 4 by x cubed. What's our answer? Answer 3x cubed. Okay, 3x cubed. Then multiply x minus 1 into 3x cubed. 3x cubed into x minus 1. 3x cubed into x. 3x raised to 4. But we write minus 3x raised to 4. Change the sign. Don't forget. 3x cubed into minus 1 minus 3x cubed, but we write plus 3x cubed. First term is cancelled. Minus 4x cubed and plus 3x cubed. Minus 4 plus 3. Minus and plus. So subtract rather from smaller and give the sign of small. Minus x cubed. Okay. Next one. 0 x square. Then divide this first term by this term, minus x cube by x. Our value is x and x are cancelled, minus x square. Minus x square. Next multiply minus x square into x minus 1. Minus x square into x minus x cube, but we write plus x cube. Minus x square into minus 1 plus x square, but we write minus x square. One thing, English 0 x square ഇവിടെ എഴുതിയില്ലായിരുന്നുണ്ടെങ്കിൽ minus 3x ഇവിടെ എഴുതുമായിരുന്നു, അതിന് താഴെ x square വരുമായിരുന്നു. ഓക്കെ, 3x x square. അപ്പോൾ ഒന്ന് x ടേം x square ടേം രണ്ടും തമ്മിൽ ഒന്നും ചെയ്യാൻ പറ്റില്ല. എക്സ് ടേമും എക്സ് സ്ക്വയർ ടേമും തമ്മിൽ ആഡ് ചെയ്യാൻ പറ്റില്ല. അതുകൊണ്ടാണ് പറയുന്നത് സ്റ്റാൻഡേർഡ് ഫോമിൽ എഴുതിയില്ലെങ്കിൽ പ്രോബ്ലം കംപ്ലീറ്റ് തെറ്റിപ്പോകും. ഈ 0 x സ്ക്വയർ ഇവിടെ എഴുതിയില്ലാണെങ്കിൽ ഇവിടെ മൈനസ് 3x കിടന്നതിനെ എക്സ് സ്ക്വയർ കിടന്ന് രണ്ടും ആഡ് ചെയ്യാൻ പറ്റില്ല. Now we can do. First terms are cancelled. This is just 0. 0 plus any number, the same number. Okay. Next. Then x square term, this is x term. So you can divide minus x square by x. Answer minus x. Then you multiply minus x by x minus 1. Minus x into x minus x square, but we write plus x square. Minus x into minus 1 plus x. Minus into minus plus x, but we write minus x. Next, what is this? First two terms are cancelled. Minus x square plus x square. Minus 3x and minus both are minus. Negative plus negative, negative. Minus 4x minus 1. Then both are linear, so minus 4x divided by x. Minus 4x divided by x. X cancelled, minus 4. Minus 4. Then minus 4 into x, minus 4x, but we write plus 4x. Minus 4 into minus 1, plus 4, but we write minus 4. First terms cancelled, minus 1 and minus 4, answer minus 5. So our answer is this. If you ignore this term, you must stop the problem on this term. Yes. ഈ ടൈം ഇവിടെ ഇല്ലായിരുന്നെങ്കിൽ ഇവിടെ വെച്ച് നിർത്തിയാൽ your answer was wrong. Okay, this is another type. Long division is a simple one. No, it's some difficult one. But you can easily understand by doing more problems. One thing, don't forget the method is same for all steps. Divide the first term by this first term and answer is here, and multiply this answer into this divisor and write the answer with changing the sign here. Okay, then you add the terms. Only one thing, if any term is missing there, you put there 0. If cubic term is missing there, you put plus 0x cube. And a term, linear term is missing there, you put 0x. Okay, that's the only one. Okay, now we learned long division. Our next section or important one is remainder theorem. Theorem based on that remainder. Before we start the remainder theorem, we can check what we mean division algorithm. We want this definition on that theorem, for we can easily prove the theorem with division algorithm. Division algorithm, the simple one. I'll explain you. Division algorithm means let p of x be a polynomial, p of x be a polynomial, divided by any another polynomial g of x, and g of x not equal to 0. Okay. In all manner, g of x not equal to g of x not, any divisor not equal to 0, because division with 0 is not possible. P of x is any polynomial and G of x is another polynomial non-zero. Degree of P of x greater than or equal to degree of G of x. We know dividend degree is always greater than or equal to divisor degree. I'll explain this number easily. 19 is any number. Okay. 3 is any number. 3 not equal to 0. Okay. Here degree of P of x is greater than or equal to degree of G of x. In the number manner, 19 is greater than 3. Okay. If we divide 19 by 19, but we can't divide if this number is less than this 2 and 3. Can it possible 2 by 3? Possible by the decimal division only, our normal division. No. So dividend must be greater than divisor on number. On polynomials, the dividend, the degree greater than or equal to divisor degree. So P of x be any polynomial, G of x be another polynomial not equal to 0. Degree of P of x greater than or equal to degree of G of x. When we divide P of x by G of x, you will obtain Q of x and R of x. You already know. When we divide a polynomial by another polynomial, we can get a coefficient and remainder. We divide 19 by 3, coefficient and remainder. Okay. Then you can write P of x equal to G of x into Q of x plus R of x. Look here. 19 equal to 3 into 6 plus 1. In other words, dividend equals divisor into quotient plus remainder. Have you heard it? Yes. In previous years, dividend equal to divisor into quotient plus remainder. If you have any doubt with the polynomial, just convert it into numbers, simple numbers. You can easily understand from the numbers. Both two number, one number is greater than another one, not equal to 0. When we divide one number by another, you get a quotient and remainder. And you already know a number can be written as dividend equal to divisor into quotient plus remainder. In the same manner in polynomial. One important property on this remainder. Maybe the remainder equal to 0 or degree of R of x less than degree of G of x. You can check here. This is the dividend, divisor, quotient, remainder. Okay. And remainder is less than divisor, this part. If we consider another number 18, 3, 6, 18, 0. Now here the remainder is 0. Sometimes the remainder may be 0 or the remainder is less than divisor. That's this case is on numbers. When we consider the polynomial, sometimes the remainder may be 0 or less than, meaning here degree of remainder less than degree of divisor. So when you considering two polynomial, P of x is a polynomial of degree greater than or equal to degree of another polynomial G of x, and G of x not equal to 0. When we divide P of x by G of x, we can attain a quotient Q of x and a remainder R of x. Then we can write P of x into G of x into Q of x plus R of x, that is dividend equal to divisor into quotient plus remainder. And the speciality of the remainder, sometimes the remainder may be 0 or the degree of R of x less than degree of E of x. This statement helps us easily we can prove remainder theorem, this statement. Now I told you what is the statement of remainder theorem. Statement. Okay, next remainder theorem. I'll explain the statement only. Statement. Then we prove on the next one. Let p of x be any polynomial of degree greater than or equal to 1, and let a be any real number if p of x is divided by a linear polynomial x minus a, then the remainder is p of x. Remainder theorem. Theorem based on or theorem about remainder. This theorem tells how we can find a remainder of a polynomial. First we cross check the definition and we check all the terms is familiar. Let p of x be a polynomial. Polynomial is a familiar term. Degree. Next, a real number. You already studied in the first chapter. Anyone? No. Linear polynomial. All terms you know. I'll explain with the example. Did you see the question? We already this question in this class on the long division. We divide this polynomial by this polynomial, we get a quotient and remainder. Okay? Do you remain the remainder? Do you remember the remainder? The remainder is minus 5 obtained there. Minus 5. You can check it. The remainder is minus 5. Clearly we did it on the long division. This theorem states a polynomial is divided by a linear polynomial. We can find the remainder. Just put what value is in a. ഒരു പോളിനോമിയലിനെ ഒരു ലീനിയർ പോളിനോമിയലിനെ ഡിവൈഡ് ചെയ്യുമ്പോൾ റിമൈൻഡർ കണ്ടുപിടിക്കാൻ ആ ലീനിയർ പോളിനോമിയലിൽ എയുടെ പ്ലേസിൽ ആരാണോ വരുന്നത് അയാളെ എക്സിന് പകരം സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്താൽ മതി. Example. This is our p of x. Okay. P of x equal to 3x raised to 4 minus 4x cube minus 3x minus 1, and is divided by a linear polynomial x minus 1. In the place of a here 1. So this theorem states just put the value of a 1 here. 3 into 1 raised to 4 minus 4 into 1 cube minus 3 into 1 minus 1, 3 minus 4 3 minus 4 minus 3 all are minus 4 minus 3 minus 1, so minus 8, that is equal to minus 5. So this theorem helps us. Without doing long division, we can find the remainder of a polynomial division. ഒരു പോളിനോമിയലിനെ ലീനിയർ പോളിനോമിയലിനെ ഡിവൈഡ് ചെയ്യുമ്പോൾ റിമൈൻഡർ കണ്ടുപിടിക്കാൻ ലീനിയർ പോളിനോമിയലിൽ ഏത് പ്ലേസിൽ വരുന്ന വാല്യൂ ഏതാണോ അത് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്താൽ മതി. ഈ ക്വസ്റ്റ്യൻ പ്രീവിയസ് ചെയ്തിട്ടുണ്ട്, നോക്കിയാൽ മനസ്സിലാവും. ഇത് x minus 1 ആയതുകൊണ്ട് 1 കൊടുക്കും. If it is x plus 1, then we put minus 1. Okay? X minus 1, it's a direct form, then we put 1. If it is x plus 1, it is x minus minus 1. You already studied minus into minus plus. Okay? Then we put minus 1 here. So this is the statement. P of x is divided by a linear polynomial x minus a. We can find the remainder by just putting the value of a on the polynomial. This is a remainder theorem. How we find a remainder? We can do the proof on our next class. We will see you on our next class. Thank you.